Continuity, Part 4. So recall that sometimes we can show that a solution exists, and about where it is, even if we cannot find an exact solution. The way we do this is with the intermediate value theorem. So suppose that f is continuous on the closed interval a to b, and that n be any number between f of a and f of b, where f of a does not equal f of b. Then there exists a number c in the open interval ab, such that f of c is equal to n. If we're using the intermediate value theorem, this means we need to show three things in order to reach our conclusion. So we have to show that f is continuous on the closed interval a to b, have n be between f of a and f of b, and we got to make sure that f of a does not equal f of b. If this is the case, then we can conclude that there exists a number c in ab such that f of c is equal to n. Remembering that c is an x value, so that's an input, and f of c, which is n, is an output. Use the intermediate value theorem to show that there is a root, or a zero, a solution, an x-intercept of x to the fourth power plus 2x cubed plus x minus 3 equals 0. If we're using the intermediate value theorem to show something, the first thing we need to do is state the intermediate value theorem. So, suppose f is continuous on the closed interval a to b, and let n be any number between f of a and f of b, where f of a does not equal f of b, then there exists a number c in the open interval a to b such that f of c is equal to n. And if you're using a theorem, it's common courtesy to state that theorem. It's kind of like a topic sentence for a proof. Now we need to show each of those three things. So first, we want to state and justify continuity, because that's like the first of our hypotheses we need in order to make our conclusion. If we look at this problem, we're not given an interval, but luckily, if we set this to be our function, f of x is equal to x to the fourth power plus 2x cubed plus x minus 3 is continuous on negative infinity to infinity, which you could also say is all real numbers, because it is a polynomial. So whatever interval a to b we come up with later will be continuous, because that'll just be like a subset of this larger continuous part of our function. And if your function's a polynomial in Calc 1, it suffices to say that it's a polynomial, and that's how we know it's continuous. Next, we need to find f of a and f of b. if you're not given an interval, that means that we're going to have to find a and b as well. And if we look at this, we're looking for where f of x is equal to 0. So that means that n is equal to 0. So we need to find numbers, outputs, on either side of 0, which means since n is equal to 0, we need to find, well, I don't need a function f for that, a positive and a negative output. And this is through just some guess and check, but some like thoughtful guess and check. What I like to do is just create a quick table. And when in doubt, some good guesses are 0, -1, and 1 for polynomial functions. So if we input 0 into this x to the 4th power plus 2x cubed plus x minus 3, we're going to get -3, which is going to be our negative output. So now we need some sort of positive output. If we substitute in -1, we're going to get 1 minus 2 minus 1 minus 3, which gives us -5. And this is still negative, so that's not going to help us. So let's try inputting 1 now. So that'll be 1 plus 2 plus 1 minus 3, which gives us 1. And this is positive. So we have our negative output, we have our positive output, which means that we have our a, which is, or b, which is 0, and our f of a, which is -3. And we have our b, which is 1, and our f of b, which also is 1. So we're looking at the interval from 0 to 1, and our n, which is 0, is trapped in between our f of 0 and f of 1. So we have our f of a and f of b. Excellent. Once you have your f of a and f of b, all that's left to do is state our conclusion. So let's just summarize these hypotheses and make our conclusion. So since f of x is continuous, on our interval from a to b, which in this case is from 0 to 1, and since f of 0 does not equal f of 1, and 0 is between f of 0 and f of 1, we can conclude there must exist a number c in or on the now open interval from 0 to 1, such that f of c is equal to 0, which means, so thus, which you can have a comma or not have a comma, x to the 4th power plus 2x cubed plus x minus 3 equals 0 has a solution. On the interval 0 to 1 by the intermediate value theorem.